morning, Dr. Kim. We wanted to come in and make sure that you're okay with our anonymous top car. We'll be doing our demonstration today. We first want to present to you our board. Going through, we want to start with our design problem as stated in the project. Our problem with our society has a problem that has been seen by most, but attempted to correct by few. Human error is the actual number one cause of vehicle collisions. We at Einstein Group Incorporated look to fulfill the need of customers young, old, and in between who will allow our product to be assessed in this issue. Now I'm going to have Josh go over the design and architecture.
So pretty much for our design, we wanted to create something that we could switch between manual and autonomous control, while at the same time, while you're manually controlling it, when you turn on the autonomous control, to avoid any obstacles in the path and still be able to move to its destination. Now, as you can see from the level 1 block diagram, how the most basic portion of the project works is that the user inputs a keyboard command, goes into the control station, then from there it sends a signal to the car telling it to either move forward, backward, left, right, and then from there, if you were to turn on the autonomous control, it goes into the local control unit, which will tell the car stop, move back, go left or right. Now when you actually go into the design implementation of the car, we came up with an analog design that worked with using L293D dual H bridge and a voltage field regulator with multiple capacitors inside the actual car. And what these capacitors were meant to do were to make sure that one, that the motors weren't getting too much voltage going into the car, and two, to make sure that it was able to power the whole system evenly. And as you can see by the voltage regulator here, this here is meant for the fact that our Bluetooth module is actually not meant to go over 5 volts. They only can hold up to 3 volts. And our voltage regulator, which is meant to make sure that it wasn't getting too much power into the module so that it wouldn't burn it out. So that's just a general basis of overview of our analog design and how how our car works, and Henry can explain more of the technical details.
Originally, when we made our vehicle using this L293D chip, it would work. Each side controls
L293D.
This is a microcontroller.
It's dual HD.
Originally, it would control each motor was based upon each side. The way it was wired, and certain things would regulate voltage to each part of the microcontroller. Now, what had happened was an unfortunate accident. We got wet, so we had to redo the design over the past week. And so, right now, it is basically an Arduino motor controller using the Arduino motor control shield, and that's what we have right now. But originally, this was controlled also in conjunction with a Bluetooth module that sent information via serial through an Android device that I helped design, and it would output functions to the actual module, and it came from motor control. Right now, this will just take away most of this right here, and what we have left is an Arduino Uno with a motor shield on top of it, and it allows for 2 motor control and also a voltage regulator. For our testing results, for our original project, everything that we attempt to do, our 3 tests, they work. It was able to be controlled manually. Also, with the push of a button, it was able to seamlessly switch over to autonomous control, and it passed a 3-foot durability test route. We finished with time to spare, but due to unforeseen circumstances, we had to redo some things, and that will be reflected in the demonstration we have today. As for accomplishing our goals, we actually bid. That's for all the works.
To conclude about our project, Thomas Toy Car, the main purpose was for it to be able to recognize obstacles within its path and to react accordingly. In the future, we plan on using like an app or a Google interface to incorporate a GPS coordinate system with our autonomous car, so it can go ahead and make its own path and be able to recognize other obstacles in its path on its own, and not have to take command with somebody. A big beginning location and an ending destination, and that's all we need. It will drive itself. And also, we are planning on sending our project to Texas Instruments by the 24th to go ahead and get it rated in the competition. Okay. Yeah, we're sending it to Texas Instruments.
And so let's go into the demonstration.
So, how is
Object is between 12
yeah,
inches.
go ahead, go running. Oh, no, it's a hold and running. Hold and running, go ahead. Okay, hold on running. Okay. Come here, oh yeah. Well, I mean, just stay like this, okay? Running continuously. How running continuously?
The way it runs, the
Huh?
program itself is meant to continuously read in different periods. It will really, yeah. It comes in every couple of seconds.
No,
and
you
reads
have to do, no, not like that. No, that's wrong.
from the ping sensor.
Oh, I thought you, no, you said, you didn't know.
The way it's running right here, as you can tell with the dim lighting, when it's actually running,
Okay.
it's not enough power.
After making this rate, now from now,
Go.
All right, durable.
Durability test.